So the first part, you're given R is this region over to the right in the first quadrant enclosed by the graph, f of x equals 8x cubed, and g of x equals sine of pi x as shown in the figure. So we want to write an equation for the line tangent to the graph of f at x equals 2. So for part A, we have that f of x is equal to 8x cubed, and this is just a problem that goes back to the first trimester when we were talking about derivatives. We have the equation of the tangent line. It's a great review though, because you can remember that we need two things for the equation of a tangent line. We're typically thinking in point slope form. So this is what we're trying to get, and we have this for the equation of a tangent line. You always need two things. You need the slope and a point. We have the point. It's given there at 1/2, 1, and so we have that. We have that the point is 1/2, 1, and we just need the derivative at 1/2. So we need f prime of 1/2. This is, I think, a non-calculator. So anyway, we figure out that f prime of x is equal to 24x squared, right? Yeah, 24x squared. Okay, so f prime of 1/2 is going to be 24 times 1/2 squared, and that ends up giving you 6. Okay, so our final equation is just going to be y equals 6 times x minus 1/2 plus 1. Okay, so that's it for part A. And you can just leave it like that. I don't know, they did on their answer key, they just left it like that, so that's fine. All right, part B then says find the area of the region. Okay, so part B, it's a lowercase b. All right, so for part B, it's just find the area, which is, we've got two equations in terms of x. There is one curve that is always above the other curve, so we can just do top minus bottom when we compute the integral, and we're going to have bounds in terms of x. So the area is going to be equal to the integral from 0 to 1/2, top curve, which I believe is the is it the, no, it's not the cubic, it's got to be sine, right? Sine of pi, yeah, g of x. So sine of pi x minus the other curve, which is 8x cubed. And we're going to integrate all of that with respect to x. All right, and again, yeah, this is the non-calculator FRQ. I don't think I mentioned that earlier, but anyway, so yeah, you've got to kind of like do this. All right, so the antiderivative of sine is negative cosine. The only thing that you've got to be careful of is if you have negative cosine of pi x, when you derive this, you'll get sine of pi x times pi. So you need to somehow build in that pi being canceled out. So if you put a 1 over pi in front, or you divide it by pi, either way, then you will you'll be able to cancel that pi out. So you have negative 1 over pi cosine pi x, add 1 to the power and divide by it, so add 1, you get 4, divide by it, you get 2, so it'd be minus 2x to the 4th. And we are going to be evaluating that from 0 to 1/2. So when you plug in 1/2, you get negative 1 over pi times cosine of pi over 2 minus 2 times 1/2 to the 4th. And then cosine of 0 is, so then this will be minus whatever's left here. So cosine of 0 is 1, so we end up with negative 1 over pi. And then obviously when you plug in 0 here, you get 0. So clear this out. Cosine of pi over 2 is 0, so we end up with 0 minus 2 times 1/2 over 4, which is going to end up being 1/8. So we have negative 1/8 minus 1 over, plus 1 over pi for the area. Okay. So then part C says, write but do not evaluate an integral expression for the volume of the solid generated when r is rotated around the horizontal line y equals 1. Okay, so just so that we're all thinking and looking at the same thing here, we have this curve that goes and does something like this. We have this curve that does something like this. ish. This point here is at 1/2, comma 1, and I drew that curve too high. Sorry. Let's make that point bigger, and we want to go around 1. Okay, so this is going to be a washer method. I'm going to sketch in the rectangle here, and then because the cross sections will be washers, I need to find the large radius and the small radius. So the small radius is, we'll just kind of write that there. The large radius is going to be there. All right, and we need to figure out what defines each of those. So the large radius is going to be 1, but we need to take away this piece here. Okay, and that piece is defined by this curve, which is 8x cubed. Okay, so it's going to be 1 minus 8x cubed. And then the other piece here is going to be 1. That's the whole thing. But then we need to take off this piece, which is defined by the top curve here, which is sine of pi x. So the inside radius, small r, is going to be 1 minus sine pi x. Sorry, that's written sort of unnecessarily small there, I guess. All right, so for the volume integral, you should get pi, integral from, and we're all in terms of x here, so it's going to be from 0 to 1, and outside radius, which is, so this is big R of x, so this is going to be 1 minus 8x cubed squared, minus the inside radius, which is 1 minus sine of pi x squared, all of that with respect to x. And I should check the key and make sure I did it right. Yeah, I did it right. Okay, so that wraps up the problem. The point breakdown on that one was 1 point for the limits in the constant out in front, the pi, and then 2 points for getting the integrand correct.